Hello students, how are you all? Welcome to Chemistry World. Today we are going to be discuss that isotopes, isobars, isotones, isosters, isodiaphers and isoelectronic species. So without wasting time, we are going to be start our session. So today first we are going to be talk about isotopes. Do you know what I mean by isotopes? Isotopes are nothing but the elements which have same atomic number but differ in the mass number. Here we have example hydrogen. So hydrogen has three isotopes, one H1, one H2 and one H3. So this is the have isotopes. So here if you are going to be observed that they have same atomic number as 1 and different mass number as 1, comma 2, comma 3. So if it is going to be hydrogen mass number with 1, so we are going to be call it as protium, and if it is going to be mass number is 2, then it is called deuterium, and mass number 3 we can call it as tritium. Okay, here we have some more example. Carbon number 12, carbon with the 12 mass number, carbon with the mass number 13, carbon mass number with the 14 is also known as isotopes. Uranium 92 with the 235, uranium 92 with the 238. These are also considered as isotopes. So I hope that you are going to be understand this what you can call isotopes. I hope that you're going to be understand this one. So let me move on to the next one, isobars. So what do you mean by isobars? Isobars are nothing but isobars are nothing but isobars are nothing but having different element but same mass number. So having a different atomic number but same mass number. Here we have example. See that argon with mass number 40 and calcium is also mass number with 40. If you're going to be observed that they are two different elements and two different atomic numbers and the mass number is same, we can call it as what you can call isobars. So let me take one more tones. What do you mean by isotones? Isotones are nothing but they have different atomic number, different mass numbers, but when we are going to be taken the difference number of neutrons and it is going to be same. So isotones are having that different atomic number, different mass number, but same number of neutrons. Example I am taking here sodium 11 with mass number 23, magnesium 12, mass number is 24. So when we calculate number of neutron, mass number minus atomic number, then 23 minus 11, it is have number of neutrons is 12. When we talk about neutrons for magnesium, it has 24 minus 12, that is going to be have 12 number of neutrons. So this is about isotopes. Isotones are nothing but having different elements, different mass numbers, but same number of neutrons is known as what you can say that isotones. I hope that you are going to be clear this concept also. Let me move on to the isodiaphers. Isodiaphers. Do you know what I mean by isodiaphers? Isodiaphers. So isodiaphers are nothing but they also have different elements, different atomic number, different mass number, but when we are taken that difference between neutrons and protons are same. So when we taken the difference between neutrons and protons are same. I am taking here boron number 5, atomic number 5 and 11, carbon I am taking here atomic number 6 and mass number I am taking here, I am taking carbon isotope here. So when we are going to be calculate number of neutrons, here we have 11 minus 5 will get a 6 number of neutrons, and here also we get a 13 minus 6 will get around 7 number of neutrons. But here protons if we calculate that is 5 and protons here 6. So when we are going to be take the difference between number of protons and number of protons and number of neutrons, so n minus p P, that will be that 6 minus 5 will get that how much? 6 minus 5 will get that 6 minus 5 will get that 1, and here we have n minus p. We are going to be taken that 7 minus 6, that is equal to 1. So when we are going to be taken the difference between number of protons and neutrons, difference between neutrons and protons, that will be same. So that is going to be named as isodiaphers. Isodiaphers are nothing but same atomic number, sorry, different atomic number, different mass numbers, but they have difference between the neutrons and protons are same. I hope that you're going to be clear this concept. Let me move on to the next concept, isosters. What do you mean by isosters? Isosters are nothing but isosters. Isosters. What do you mean by isosters? Isosters are nothing but so different elements, different atomic numbers. Sorry, isosters are nothing but they have same what you can call same number of atoms, and isosters are nothing but having same number of atoms and same number of electrons. Now I am taking here example as carbon monoxide and nitrogen. These are the molecules contain that same number of atoms and the same number of electrons. See that I am taking here number of atoms. Number of atoms in the carbon monoxide is 2, and whereas nitrogen molecule also 2. So when we are going to be taking number of electrons, for carbon it has 6 electrons, for oxygen it has 8 electrons. So when we calculate the total number, it is contains that 14 electrons. Here we have two nitrogen atoms. One nitrogen atom contains that 7 number of electrons. So it is going to be contain total 14 number of electrons. So when we are going to be taken here, same number of atoms are there and same number of electrons also is there. So we can call them as isosters. So the species which contain that same number of atoms and same number of electrons is known as isosters. So we have a last number, that is isoelectronic species. So do you know what I mean by isoelectronic species? The species which contain that same number of electrons. Isoelectronic species. Isoelectronic species. Isoelectronic species. What do you mean by isoelectronic species? Same number of electrons contained at the species. Okay. For I am taking here example N3 minus O2 minus F minus Ne. See that N3 minus, actually nitrogen atomic number is 7. So generally it gains 3 electrons. So it contains that total number of electrons is 10, and oxygen atomic number is 8 here. It gains 2 electrons. Total number of electrons is 10 electrons. Fluorine atomic number is 9. It gained 1 electron. So total number of electrons are 10 electrons. And neon is also have 10 atomic number. We know that 10 contain. So these are the species containing that same number of electrons. So we can call them as isoelectronic species. So we'll go with some more addition with that. Sodium plus. So generally sodium atomic number is 11. It lost one electron, going to be get a plus charge. So that's why it contains that 10 electrons. Magnesium, if you taken that magnesium 2 plus. So magnesium atomic number 12. It lost 2 electrons, contain that 10 electrons, and Al3 plus. If you're going to be taken that atomic number of aluminum is 13. So it is also lost 3 electrons, contain the 10 electrons. So these are all contain that same number of electrons. So we can call it as isoelectronic species. Okay, right. Let me go with one more example. So here H2 minus, Cl minus, and argon, and K plus, Ca2 plus. If you're going to be see that sulfur atomic number is 16, it gains 2 electrons. Total number of electrons will be 18 electrons. Chlorine atomic number is 7, it gained 1 electron, so it's going to be contain total 18 number of electrons. Argon is 18 atomic number, it contains that 18 electrons. Potassium atomic number is 19, it lost 1 electron, going to be get plus charge, so it contains that 18 electrons. Calcium also atomic number 20, it going to be lost 2 electron, it going to be have a plus 2 charge. So by attain that they have 18 electrons. I hope that you are going to be understand this concept isoelectronic species. Isoelectronic species are nothing but the species which contain that same number of electrons. I hope that you are going to be clear this iso concepts. So I hope that you're going to be clear these concepts. Thank you very much. So if you like the video, please do subscribe my channel and share my channel. Comment in the comment box. Thank you.